Hi everyone, welcome to my YouTube channel FIME. This video is for students of chemistry O-level and igcse syllabus preparing for the academic year 2024 till 2025. Chemistry topic is for this video states of matter. We are going to talk first about how many states of matter there are. So there are 3 states of matter: solid, liquid, and gas. How are solid, liquid, and gas different from each other? Like, what are the properties of each? So for solid, its shape is fixed. Its volume is also fixed. Solid is not compressible. Neither solid can flow. Now heading to liquid. Is liquid shape fixed? No, liquid poured into any container takes the container's shape, unlike solid, so its shape is not fixed. Liquid volume is fixed. Liquid is not compressible just like solid. Liquid can flow. Gas shape and volume is not fixed. On the other hand, gas is compressible and can flow. Solid, as it cannot flow and has fixed shape, it's due to the particles arrangement that way inside a solid object. The particles are arranged in fixed position and they only vibrate, they cannot move. Liquid can flow and does not have fixed shape. It's due to the particles are loosely packed that particles inside the liquid could easily move around. Gas, whereas can flow, does not have fixed shape and is compressible because its particles are spread apart, moves in any direction, and there is very less force of attraction between the particles. All the points written here are summarized, so let's move on. Now let's talk about the subtopic of the topic states of matter in the syllabus. Describe the changes of states of matter. Melting happens when the solid's temperature rises enough that it reaches its melting point, and so the solid starts to slip away, as in the form of liquid. Boiling is about liquid when a liquid's temperature rises to the liquid's boiling point. The liquid starts to vaporize by bubbles forming inside the liquid and then coming near to the surface of water, bursting and releasing gas vapors. Freezing is the process of liquid becoming solid. It's when the liquid temperature is lowered enough that it reaches the liquid's freezing point. And so the liquid's particles start to lose energy, coming closer together and stop moving, hence the solid taking its shape. Condensing is when the gas vapors in the air meets cooler surface. They change state to liquid and appears as water droplets. Evaporation is the change of the liquid's state to gas in evaporation. There is no need of the liquid's temperature to reach its boiling point. The mechanism of evaporation is different than of boiling. Now let's dive deeper into the changes of state. As for melting, take an example of ice cream. It's solid when you take it out from the freezer. It becomes liquid as you eat it, like it starts to melt. Why is this so? Your room temperature is hotter for the ice cream to be able to stay in solid state. The particles of it gains a heat energy and start to move, breaking apart from their fixed position, hence taking the state of liquid. Condensing. Okay, see the example below. A part of a water bottle is shown. It's cold water bottle and it has some water droplets outside it. As we all experience this sweating of cold water bottles taken on a hot day, is it the water inside the bottle coming out of the bottle onto its surface? No, it can't be. Rather, the truth is that the water vapors in the air, when come into contact with the cold water bottle surface, they lose their heat energy and their state changes from gas to liquid, and they appear like this on the surface of cold water bottles. Freezing is liquid particles lose their kinetic energy and so their state changes. We have talked about this in the previous slide. So boiling, it's when the liquid particles gain heat energy that they start escaping as gas. And lastly, non-evaporation. Evaporation is when liquid particles gain enough heat energy that they start to break apart. Okay, the confusing stuff should get cleared. So, what's the difference between evaporation and boiling? Well, it's quite simple. Evaporation is gradual, like layer by layer of water. First, the top layer evaporates, and then the beneath layer comes top, and it evaporates like this. It goes on until all water has been evaporated. Evaporation does not require the water to come to its boiling point. Evaporation is primarily relied upon sun's heat. Okay, now boiling is the opposite of evaporation. Like it requires water to come to its boiling point. Also, it's much faster than evaporation. It is not dependent upon sun's energy, rather any other source. Like here in the picture, there is a Bunsen heating and cooling curve. It's quite interesting. First, talk about heating curve. This is temperature seen on the y-axis and the time in minutes on the x-axis. A curve in red is labeled A, B, C, D at some points. A is the point of starting, B is the point of melting, C is the point where melting has been completed, and after C till D, just the temperature increases and there is no state of change. The trend of the graph is that as time goes by, the temperature increases. Cooling curve, the curve is in blue. The trend visible here is that the temperature decreases as the time goes by. At point A, and it's the starting point, the temperature of liquid taken, it tells. At point B, it's the freezing point where the liquid starts to change state to solid. It goes on till point C. After point C, there is no state change. This is a diagram targeted to best explain each stage, A B till B and B till C, C till D of either graph. As explained before, this graph conveys the same information in written for clarity. Let's talk about gas, in particular its volume. Like what happens to its volume when temperature and pressure is increased. So when pressure is increased, the volume of gas decreases. It's because we are trying to make the gas molecules come closer together, and for that we are applying pressure. That results in gas state change as it comes to a liquid state, but as soon as the pressure is released, it reverts back to its original gaseous state. Like in childhood, we all must have played with a syringe, blocking its plain tip so no air escapes, and some air is captured inside it, and then using the plunger pushing it down. While it was not easy to push it down due to the already there was particle present inside it, but if pushed with enough force, it used to got pushed enough, meaning we did decrease the volume of gas by bringing its particles closer together. As the particles get more energy, the particles spread apart more, like bumping each other more frequently, and that's how they use greater space. This concept is widely used, and the picture at right of an hot air balloon has the same concept used. The gas is filled inside the balloon. The heating element is placed at the opening of the balloon, which heats the air up, and so the gas volume starts to increase, which in turn lowers its density. And warm air density is less than the cold air, so the balloon starts to rise. Thank you guys for watching. Hit the like button to motivate me to make more such content, and type in comments your any queries so that it could be solved and other students gets benefit too. Also, if you have any feedback on my content, feel free to write it in the comments section down below. See you in the next video. Bye.